Last off, we have Vladimir, who's an architect. He has years and years of experience, and he's also a big React fan. He also wrote a book on the topic, and today he's going to show us how to make applications with React Native and GraphQL as the backend line.
Yeah, thanks for the introduction. Hi everyone. Really excited to be here and to talk about awesome tech. Before I start with the whole presentation, a little bit about myself. So I'm Vladimir Novick. I'm an independent consultant who work for various clients across the globe in web, mobile, virtual reality, augmented reality, mixed reality, and the Internet of Things field. And this is my Twitter handle over there. My website for some reason got cut off, so just follow me on Twitter if you want to keep up with things I tweet and etc. So this is the book I wrote and published last August. It's basically about React Native and building mobile apps with JavaScript. You can guess that by name. And the book is focused on teaching you building mobile apps with React Native based on real apps approach, meaning you will learn to build WhatsApp, Instagram, Tinder, Twitter as a final project, and so on. Enough of shameless effort. Before on into React Native and GraphQL and all this hardcore stuff, I just want to ask a couple of questions. Who of you used React on a daily basis or use it? Okay, who haven't seen React at all in his lifetime? Who seen React, haven't played with React, but okay, cool. So you have at least, the majority at least have seen React. So the same question about React Native. Who have seen React Native? Okay, you've seen yesterday, yeah. Yeah. So the idea of React Native is letting developers to build mobile apps in JavaScript, but it was already there with Ionic and Phonegap and Cordova, all this kind of stuff. But React Native took a different approach because React is based on the idea of React is a component-based approach on top of the idea of virtual DOM, and keeping the whole hierarchy in memory and rendering to specific target. React Native actually, instead of it cannot be called as a hybrid app framework. It's more mobile app framework because JavaScript is rendered to the actual native code, meaning you have Objective-C, Swift, Java, or Kotlin running on the device. So in general, React Native and development React Native looks pretty much the same as it looks in the web development. We have simulator running on the right side. When you change stuff in your editor, you get instant updates. You don't have recompilation, which you usually have on mobile. And you can do various stuff. You can have hot reloading, similar to what you have on web, when parts of code are reloaded and not the whole app. You can inspect things. You can debug architecture of the actual views in your app. Something that mobile developers dreamt about for years, or even haven't dreamt about that. So the video just goes on with various techniques, so I will just skip the video. Okay, React Native is out there. Mobile applications are built with React Native. It's a trend. It's not only a trend. Lots of new startups and even old companies adopt React Native because of the fastest development, great developer experience, the hybrid, not the hybrid, the cross-platform nature. You can develop in JavaScript. You get 90% of coverage between platforms. You get here and there changes for Android or for iOS, but generally 90% of code reuse. And even you can write the same way as you write in React Native and run with React Native web, which will render it to the web, which is a new kind of new thing right now. So the talk is about React Native, GraphQL, which will be the second part, and about data-driven mobile apps. So let's ask ourselves, what are actually data-driven mobile apps? Basically any apps right now in current age, because any app is driven by data. Any app gets the data from the server. Any app want to be real time. We don't want to wait for things to happen. We want instant update. We want everything to be on our phone right now, right? So basically any app driven by data, which is probably every app, is data driven. But when we develop such app, and in general, when we develop mobile apps, we should consider various things: authentication, network, synchronization between maybe offline and online state. If you, especially for mobile, when you go, for example, you ride in a subway, you go into a tunnel, network cut off, you want to be synchronized with the network state when you get out of tunnel. Offline data access, state management. There are lots of libraries out there. The major ones for React and React Native are Redux, Mobix, Mobix State Tree. Buzzwords you probably heard about. Real-time data. Real-time data meaning we need, we cannot do polling mechanism anymore, right? It's like from several years ago. We cannot poll server all the time, especially on mobile, because user, we don't know how much person pays for his mobile package, right? We don't want to poll server all the time, and we query a large amount of data. So we need some kind of subscriptions. We need to push updates from the server to the app. And yeah, when we think about all that stuff we need to think about when developing an app, it can be really overwhelming. Especially like you start to create an app and you think about all these things, you need to develop architecture for this app, and come on, really, I just want a simple app. So today, what do? Well, the basic idea, right? Mobile, we had web servers that are obviously in the cloud because everything is in the cloud, and it hits database, right? So that's the architecture. Not really. We have subscription, then we have WebSocket servers, which get updates from PubSub servers, which get updates from web servers. So we need to develop our architecture like this, right? But we are in the cloud, so we can add another thing like Lambdas, streams, DynamoDB, Elasticsearch, streams going into Lambdas, into Elasticsearch, and whoa, it gets too much. So that's why we have DevOps jobs, right? To do the whole thing, and then for us, develop only for mobile, and okay, you care for that part, do this complex stuff. But the major problem is not with the architecture, the major problem is with the rest. Because let's say about that, we want to get posts, right? So we hit posts endpoint, then we get post with ID, and author with ID, and post with ID and comments, and it just grows, right? If you have a mobile app and a web app, and for some reason mobile app want a little bit different data, well, what basically you do, you go to the backend team and say, hey guys, I need more endpoints. And it just continues to grow, which means not really maintainable, and meaning each time we need to add more and more queries and more and more fetch requests. So, what is GraphQL? Any of you have seen or tried GraphQL? Cool. So GraphQL is a query language for API. So basically it looks like this. You can see from the back the code? Or yeah, so it looks like this. We query something. Yeah, there's plenty of space over here, so just move here. If we can get lines of code, something like that. So we query the data, and we get the same data, the same structure of data we query. Let's say the example, we query posts with ID, title, published, We want the name of the author and content of comments. But usually, like, let's say we use REST. So we will hit post endpoint with specific ID, we get the post with author ID probably. When we hit another endpoint for author data, we'll get not only the name, we'll get the whole thing, the whole author data. And for comments, oh my god, because it's really bigger. We get just an array of IDs here in post request, and then if we want specific comments, for each one we will get the comment, right? So it just grows. And for GraphQL, we just query the data, we get the data. We don't need to hit numbers of endpoints, we just get it. So another concept called mutations. If you want to change the data, modify something, stuff like that, then it's called GraphQL mutation. It essentially looks like a function. You pass several variables to this function, and you get the data you want. You mutate the data, you get the data back, and actually here you can query on this data and get the specific things you want. For example, here I create a draft of the post. Back I can get the whole post, but I don't care about the whole post. I care only about ID and published flag, if it's true or false. So I just state that in mutation, and I get only this data. So meaning also the network traffic becomes lower. So another thing with GraphQL, with the mutations, we can define variables for our mutations and pass them to a mutation from outside. Meaning now we can embed it in the code, use it, and we have only one API. So let's check out, we are like a space-themed conference, right? So let's look a little bit about Star Wars. So there is this open API called Star Wars API, and it's a REST API with a bunch of endpoints. For example, I have people and ID. I get a bunch of data. On this data for films, I get other endpoints, REST endpoints I should hit to get the film data. Same for species, vehicles, star shapes, stuff like that. So meaning if I want to get a person with homeworld with a list of film names, it has its species, I need to, like, how much it was, we hit 5 endpoints, 5 requests for just getting the data. So in GraphQL it looks like this. I query all people with, I want from people collection to get name, to get species. Remember here it was another endpoint. But I state here I want the name and the language. From film collection I want all films with the title, and for homeworld I want some physical data for some reason, I don't know. And I want even a resident of this homeworld. So it's kind of 6, 7, I think. REST API requests, right? And instead of that, I request once, I get everything aggregated and served to me as it's supposed to look, right? So this is the new way that eventually will replace REST, and it replaces it in various startups and even big companies. So, for example, for posts, the same thing I showed you. I have posts, I want to get title, to get ID, content, if it's published, blah blah blah. I can execute it, and I get posts. I can create draft, I can add comments to a post, publish, stuff like that. And for example, if this is public API available, right, this is GraphQL, like simple GraphQL server that was written in 100 lines. So it's not that big thing to write that, right? The question is, where do you take the data from and how you aggregate it? So let's get back to the keynote. Okay, so GraphQL introduced its own SDL, like language for the schema definition language. This is the literature. So do I have pointer here? Yeah. So on the server side, in order to define my queries, I define a type of query, and I define posts, array of type post. And I also define post with ID that returns post. What does it mean? It means if I query for post, I will get collection of posts. If I query for post and pass specific ID, I'll get specific post, right? So then I have this type, which is post. I get ID, title, content, publish, author, and comments. And these two are also types. So, whoops. So author is just ID and name, and potentially you can add more if you want. It's just like a simple example. Comment is just ID and content. And here you see comments get an array of comments. So mutation type looks like this. Create draft will get title of type ID. Meaning, if you pass a number, you will get an error that type is incorrect. So it's also typed, and you get this in the response. You also can see that the type is incorrect or something, and it's required. Content, author, I can pass all three. I get post back. I can add comment, then I get the ID of specific post. I can delete, I can publish, can do various things. There's much more in GraphQL. There's like union types and various fragments, subscriptions, different concepts. I won't go into every one of them because it's a big topic, but if you look at the logic of it, it's really logical. Like you have types, you just define them, and you query for the type for specific data based on queries or mutations or subscriptions, and you get the data in the format you defined. So you're in charge how the data will look like. So to do that, you need to create resolvers. Resolvers are essentially that piece that connect between SDL, the schema definition language, to database, API, Lambda, whatever you like. For an instance here, I don't use database. I just have like array on a global scope. I know, just like an example with posts. And if I query for post, I just find the post by ID in the array and just return it back. For mutation, it looks not so complex. I get parent and arguments. Basically, everything I pass to mutation gets inside arguments. And then I just define a new post with just new ID with weird unique ID. It's not unique. Really. So I get title, content, comments, author, published, false, and I just push into this array and return it. So this is like, as I said, like 100 lines of code, but you can do that, like connect the actual database to that, or connect even various databases to that. Or even the whole nature of GraphQL is aggregating the data based on the your actual resolvers and your schema definition language. Meaning, if you already have existing API with REST endpoints and you want to create something for mobile that retrieves part of this data, you can inside your resolvers, instead of just finding things, you can make your resolvers hit the API, the specific endpoints you want, aggregate the data and return back to you. Not so performant, but I mean, if you have an app and you want to try GraphQL, and still it's better than hitting lots of endpoints from the client. What's on the client? There is Apollo project, not the one they landed on the moon, but the different one. It's called Apollo GraphQL. Basically, there are various solutions for integrating with GraphQL from the client side. The oldest one called Relay, you probably have heard about that. There is Apollo, and there is a new one by Formidable Labs called Urkel. So Apollo is kind of a popular one and a standard currently. So for Apollo, if we want to connect our React Native app or React app or whatever, it will work with React app too. We have two ways. We have Apollo client, which was out there for like I think more than a year. I'm not sure about the timing, but and there is you need like various configuration, because if you want, for example, caching mechanism, offline data usage, you still need to configure things. So it's more low level. Syntax pretty easy, but still you need to consider lots of things. And there is Apollo Boost, which is super straightforward. I think it was open sourced this year in February or something like that. And basically gives you everything out of the box from the start: authentication, error management, local state management. And even you can combine state management from the server and from your local state management system, meaning you don't really need those systems. So I'm not saying it's killing Redux or Mobix, but you can use just Apollo for the whole state management. Then you just query even your local state with GraphQL. So how do we set it up with Apollo Boost? Because it's simple. We yarn add or npm install if you favor npm more. Apollo Boost, React Apollo, GraphQL tag, GraphQL, and we don't need save because it's yarn. Then we just set it up by just creating a new object, Apollo client, passing your URI of GraphQL endpoint. The example I showed you is basically the local server I'm running, port 5577, GraphQL. So I'm hitting it. And then you start writing your queries. How you write them? You have the GQL, which is GraphQL tag, and this is basically the parser of your query into schema definition language. You open a template string, close a template string, in the middle you write the query. As simple as that. Just have bunch of, and actually you have syntax highlighting for major IDs. So even though you write template string, it realizes it's GraphQL, so you get syntax highlighting for variables and stuff like that. So this is like the simplest example, running not in React, Angular, Vue, whatever. You just in plain JavaScript. You just create a client, query, and you get the data and just console it. So for queries in React, what do? I import query from React Apollo. Same idea. I get GQL. I execute GQL and the actual query, define the actual query, sorry. And then I have this fancy syntax. In the new trend in React is using the concept called render prop, which means between the JSX tags, instead of rendering the actual components, I will render a function that my component will execute with some parameters, and as a result we'll return components or whatever. So Apollo Boost is based on this concept. It's kind of trendy and everyone uses it, and it's really neat. It may look intimidating at first, but I don't need to fetch anything on component bit mount. I don't need to take care of the loading state flags, error state flags, anything. I just get it here in the render prop. Meaning when I pass this query, automatically I get in loading, error, or data. And I can, based on this, I can return my components. I can, or in this example, I'm returning loading text, or loading error, or I can just render my posts. So for mutations, the same idea. I define my query with JQL, then I execute my mutation. It's more complex here. I execute mutation, I pass the one I defined. Then I have the update function, which is not necessary. Actually, update function is executed if you want to reload your cache. I told you that Apollo kind of caches things, right? Apollo Boost caches things. So when you execute mutation and you get the data, sometimes you want to, most of the times, but sometimes you don't, you want to reset your cache, or you want just to reload your cache, do queries and just add them to the cache. So that's what I do here. When I execute mutation and I get just the ID of post, but I want to refresh the whole list, so I do update function here, write query to the cache, and my cache automatically is reset. So and here the same thing. I don't get loading and error thing because it's a mutation. I get the first argument, which basically a function I can execute to execute this mutation. It sounded weird, right? Execute a function. Okay. So I get the data from outside, and basically I can add on press callback here to create post. For those who haven't seen heavily like React Native stuff like that, this is just a button on the device, right? On press is on click for React Native. Fastest explanation of React Native ever. Yeah, okay, so let's see how it looks like. So this is the device, and I get shameless plug about my book. So I get the post, I can create new post, add a title, whatever content, create draft. Anyway, you see I have it here, so I can create another one. Hey, title, something, create draft, and I get another one. It's refreshed, and I get the data, any data I want. So that's how it works on mobile. So the next thing I want to talk with you about, we talked about React Native, we talked about GraphQL and how cool they are. But in the beginning, I showed you the whole infrastructure thing we need to think about, right, when developing apps. And I didn't answer the question like how we do that. Okay, we have GraphQL. It solves one problem, REST, right? But do we do what do we do for the whole infrastructure, for the whole backend? Do we still need DevOps teams to create this whole systems to be scalable, maintainable, stuff like that? Well, it's usually good to have DevOps in the company, but there's one service that was opened up, like I think several months ago, something like that. Not so long ago, maybe half a year or something like that. It's AWS service, as you can understand by a prefix. It's called AWS AppSync. So basically, what it gives you, it kind of abstracts everything for you. You have your client, you get your GraphQL proxy, the rest Amazon can take care of. You have subscriptions, you have the data, you have the tables, you have everything. You don't need to do anything, just configure your schema in GraphQL, put it on the servers, it will take care of everything. So it's really cool, right? So how it looks like. This is like a regular AWS console account. I just searched for AWS AppSync as one of the services. When the window opens up, I can create new API with the service. When I create API, for example, I have two APIs created here. It basically shows me this window. So it created API for me, and I have specific credentials. We'll look in a bit in actual console how it looks like. But in general, you get in this window with the schema. You can, instead of writing your own server, you can just write the schema here. You can hit queries and query your own schema. you see, probably in the back you don't see it, so I will read it. On the left side we have data types that you define in the schema, and create resources button. So AWS takes care of creating resources for your actual needs. So if, for example, you want to create posts, right? So you define query, post, you define mutation, create draft, whatever, you define post, author, comment, stuff like that. Then you go into create resources tab, you get like drop down, what do you want to do? Do you want to connect DynamoDB tables to your as your resolvers? Do you want to connect AWS Lambdas? Do you want to connect anything else? And when you choose, it automatically creates these resources for you, and it automatically writes down the resolvers for you. So you don't need to write your own resolvers; it writes them for you. But you have you can see them, so you can modify them to your actual needs. For instance, if you don't want to write the data to database, you want to hit external API, right? So you either can write your own resolver in the service, or you can just go to create Lambda function and like create Lambda function that will hit this external API and connect your AWS AppSync to that. So the client setup for the AWS AppSync is pretty straightforward. Bunch of libraries, actually two libraries that you bring, three. You bring AWS AppSync, this is the actual client you will use on mobile. You bring Rehydrated, which basically knows how to store your state locally and how to rehydrate your state when your device goes out of offline mode to online mode. Then we get auth type, GraphQL, Apollo from React Apollo, I showed you before, and AWS SDK, and bunch of configs. So in order to use AWS AppSync, we can choose several authentication methods. The one I use, this is just a sample app. It's just a hashed ID I can pass as a config. It will authenticate me to AWS, and I will be able to perform anything on configured in AWS AppSync. But I can, instead of that, use AWS Cognito for actual authentication and proper user management, right? And various other Amazon services. There is a library called AWS Amplify. This library gives you access to various services, including authentication, so you can use the too. Then I create the client. I pass it URL with GraphQL endpoint, region. AWS is focused around regions, right? So today I opened my console, and because like geographical change, I haven't found any demo apps. I was like, what the hell? And it was in different region. So an author type is just API key here, and as I said before, you can use whatever authentication you want, and AWS supports. And in the main app.js in React Native or in React, you use Apollo provider to wrap everything in Apollo, or passing the client. Use Rehydrated, as I told you before, for rehydrating the local state and the actual app component. So queries and mutations can be used, as I showed you before, with Apollo Boost. But there is another way you can use queries and mutation. Instead of like doing, if you don't fancy these components with the render prop thing, you can do stuff like that. You can pass the query with some options, get some props back, configure things on the props, and pass variables and stuff like that. So you can do various checks on the response. Like here, you can check the type names and next tokens for pagination and stuff like that. So let's see how it looks like in action. So this is AWS console I showed you before. So for example, here I have sample post app. when I open it up, I get API URL and auth mode that I showed you I used in the client, right, for authentication. So I can open it. I can just use it. There is actually AWS AppSync comes with a demo app you can use for iOS, Android, web, or React Native. As simple as cloning this repo, downloading the config file with these actual credentials. Schema is, you don't have to download, it's just there. So if we go into schema, I see the same, kind of the same schema I've showed you on the server I created, but I have a bunch of things. Sorry. I have put post, create post, update post, delete post, post connection, subscription, updates, stuff like that. No one of them I've written myself. So it assumed if I create a database table, I want basic RAD, right? So everything was created for me. When I hit this create resources, I can check on post, create post table, primary key will be ID. It just shows me what I should add to my schema. So I don't actually need to type most of my schema, it's created for me. And the amazing thing, let's get back to the schema. You see here this kind of annotation, AWS subscribe. So remember the PubSub servers and WebSocket servers that we need to configure to get subscriptions? Well, it does that for you. So it configures AWS resources for you, and you can just subscribe for changes and get WebSockets connection and real-time data updates that are pushed from the server to the client. So it's really cool. You get, for example, data sources. If I go here to data source and I go to the post table, it will actually redirect me to the AWS DynamoDB with post table. And if I go into items, I actually see my items. So everything in Amazon, so everything is interconnected, right? And speaking of apps and how it looks like, hope it will work. Let's event up. So this is it's in action. It's AWS AppSync connected to this app. So I can create a new event. I can set up location. I can add some info. I save it, it's already here, right? Now, let's take a look. Let's go to Basic Events app. That's the actual applications connected to. Data sources. I have AppSync event table. I go to this table. Go to items. It's here, right? So as fast as that, it's already in database, it's already there. So you can also subscribe. It's everything real time, everything is updated. So the main point and the takeaways I want you to take from this talk is start using GraphQL for better API handling. Even if you cannot do it in your company, try to play with it. AWS AppSync doesn't cost anything, I think. It's on the same model as AWS Lambda, meaning for execution, you pay for execution. If I remember correctly, for Lambda execution, you pay something like 1/1000th of a cent, something like that. So it's really cheap, unless you have an app with millions users, maybe it costs you $10. And use Apollo Boost on the client. At least start with it. If you want to add more features, start looking into a caching mechanism, customize things yourself. It's really easy from Apollo Boost to go to Apollo client and set up more configuration and stuff like that. So for custom server, I've built it. There is a package called GraphQL Yoga. Let me just show you really quick. how it looks like. This is the whole server. This I said 100 lines. Sorry, it's 70 lines. So I just import GraphQL server. I have just stupid ID 0 that incrementing posts, well, just an array. Have query, mutation, add comment, delete post, publish. I pass type definitions, which is schema defined here. And as you can see, I get syntax highlighting. I define my resolver, and then I just state that it will be on port 5577, GraphQL, and Playground. It's the fancy dark theme I hope you've seen from the back, the actual code there. So actually, if you start the server, you will get this built-in as a debugging tool. And you can define, this will be my GraphQL endpoint. But I want this Playground only for devs, only for debugging, so I'll put some weird URL nobody will find ever, I hope. And yeah, and you can debug things there. So yeah, back to, so takeaway, start using GraphQL, Apollo Boost, GraphQL Yoga for custom server, AWS AppSync for all-around solution with everything. On a daily basis, it's adding more and more things. Subscriptions are relatively new. They were not out there a couple of months ago. Now you can do subscriptions. AWS mobile team working heavily on that part because it's really need for mobile apps mostly, because from mobile apps you want real-time data, and the whole architecture, as I showed you in the beginning, is really complex. So doing that for you is a good way. And the thing is, most of I don't want to say anything about Google Cloud Platform or Azure, but like lots of companies use AWS. It's not like different service or something out there no one aware of, right? It's AWS, everyone uses, everyone loves. So yeah, subscriptions for real-time data. As soon as you need real-time data, you need WebSockets connection, and you need WebSocket server. Actually, the fleet of WebSocket servers to maintain that. And AWS AppSync does that for you with subscription, so it's a good thing. And thanks for coming. If you're interested, like in consultation, workshop, in the company, as I told you, in the independent consultant, so just contact me on the website. So it's good I wrote it here because it cut off there. I also all my social accounts there, so if you just feel like saying hi or something like that, feel free. And yeah, if you have questions, we have several minutes for questions, right? No? 1, 2 questions? Yeah.
So GraphQL is a middleware between your database and Nginx.
No, it's kind of similar.
Or it's another type of architecture for an API.
It's another type of API and another concept. Like instead of, like REST was fairly new 10, 12 years ago, right? So something like that. Before that, there was always page reload and all of stuff like that. No single page apps whatsoever. Maybe more than 10 years, I don't know. So you can think about like the modern way to do API.
Okay. So the SDL is a new type of database, practically.
It's a new type system.
Okay.
Database stays aside.
So you can integrate with MySQL database.
You can. I just showed DynamoDB. With the AWS AppSync, you cannot because like it's AWS resources, and you probably don't want to integrate with relational databases when you are talking about real-time data, because mostly when you're talking about real-time data, you need graph databases and you need some tool to connect all these dots. So GraphQL basically does that for you. You don't need relations anymore. You just need blob of data and query language to connect everything. And it's more performant, more real-time.
So
you
you have to move the information from SQL
No, it also integrates with SQL. It can be like.
With want this new performance, you
Mhm.
have to move the data from MySQL to GraphQL.
It depends on the amount of data. GraphQL is not a database, so it's in between. It's instead of doing REST, you do GraphQL. So database stays aside, right? So if it depends on your needs, on your company needs. We can discuss on the break like more in context. Yeah. Other questions? Okay, so
Okay,
we're good.
then.
Yeah, so we can discuss now. Yeah.
Let's give Vladimir